Okay, question number 19. So an object performs a simple harmonic motion at frequency f, distance between the extreme positions at which the object is at rest is b. Okay, this is b. What is the speed of the object when it's halfway between its equilibrium position O and its extreme position? This is its position. Okay, somewhere at this point, what is the velocity? So which formula will you use? You will use a formula which is b square equal to omega square into a square minus x square. Now he is asking you this value. What is A here? Amplitude. What is the amplitude? This distance should be amplitude. It is one more misconception students do. So what you should do is you take this A to be equal to b by 2 and not b first. And what is the value of x here? This is the value of x only. What is this value? X should be equal to b by 4. Why b by 4? Because this is nothing but a by 2. Half of this one is nothing but your amplitude. Half of this one is nothing but your x volt. Therefore, you get this answer b by 4. Now let us plug in these values. I get the answer as omega into omega square into a value is b square by 4 minus x square value. I square this will become b square divided by 60. And let's simplify this. You get this omega square b square divided by 4. I take it common and I'll write this 1 minus 1 by 4, which should be omega square b square divided by 4. So I take the LCM here, I get this 3 by 4. So thus omega b square as b is equal to square root of omega square b square into 3 divided by 16. When I do that, I get omega b root 3 divided by 4. See here, no omega now. I'll substitute for omega in terms of frequency. I'll write it as 2 pi f b root 3 divided by omega. What did I do? I substituted for omega as 2 pi f, right? 2 1s are, 2 2s are. This final answer I get here should be pi f b, maybe root 3 I'll put here, divided by 2. Take everything, pi f b root 3 divided by 2. Root 3 pi f by 2. So answer should